Welcome students to Kkhyatis Education. I am Aalok Guptaa, your mathematics mentor and coach. So yesterday we had a marathon session where we cleared all the 4 chapters of trigonometry of 9th grade ICSE board. Today we are going to cover the entire, again a marathon, we are going to cover the entire 10th grade. I am going to I'm going to solve the problem from ML algebra because that I believe it has got quite a good sums, which is definitely going to prepare you for the kind of questions that are being asked in the boards, in the 10th board. So let's start. So yesterday we had learned about all the concepts of trigonometry. I have shown all the concepts along with the proofs. So this lecture, before you see this lecture, I would recommend that you go and see those videos and get your concepts much stronger. The first sum goes like cos square 26 plus cos 64 degrees sine 26 degrees plus tan 36 degrees upon cot 54 degrees. We have to find the value of this. So, like I told you, this is a typical sum which belongs to the complementary angles. So 64 plus 26 is 90. So I will do cos square 26 degrees plus. Now if I can have sine square 26 here, that will make my life easier. So I can write cos 64 as cos 90 minus 26 because 90 minus 26 is 64. Then I will write it this as sine 26. Okay, tan 36. 36 plus 54 is 90. So I can write this as tan 90 minus 54 upon cot 54. Okay. Now this becomes cos square 26 degrees. Cos 90 minus 26 is sine 26. And there is one more sine 26 degrees here. Tan 90 minus 54 is cot 54. So this becomes cot 54 degrees upon cot 54. So now this becomes cos square 26 plus sine square 26 plus cot 54. Cot 54 will get cancelled out. It becomes 1. Now we know the identity sine square theta plus cos square theta is always 1. So sine square 26 plus cos square 26 also would be 1. So this answer is 2. Okay, let's move ahead. The second sum that we are trying to do is cos square 25 degrees plus cos square 65 degrees plus cosec theta into sec 90 minus theta minus cot theta into tan 90 minus theta. Okay. So we have to evaluate, we have to find out the value of this expression. So how we can write it as cos square 25, I will keep it as it is. Now this cos square 65, I can write it as cos square 90 minus 25 because I have a cos square 25. My intention is to bring sine square 25 here. That's why I wrote 65 as 90 minus 25. Okay, cosec theta, I will keep cosec theta as it is. This sec 90 minus theta, the complementary angle sec 90 minus theta is cosec theta. So this will become cosec theta minus cot theta, I'll keep as is. Tan 90 minus theta will again become cot theta. So now these expressions are going to change as cos square 25 plus. Now cos 90 minus 25 is sine 25. So cos square 90 minus 25 will be sine square 25. So I will replace this with sine square 25. Okay. Plus cosec theta into cosec theta is cosec square theta and minus cot square theta. Okay. Now this will always be 1 because we know the identity sine square theta plus cos square theta is 1. And again, this will be also 1 because we know the identity cosec square theta minus cos square theta equals to 1. I have proven all these identities. I have explained the concept well in my previous session. So please go and look at this. So this will be 1 plus 1, which is 2. So 2 is the answer. Let us try to solve some sums which are sums where we have to prove left hand side equals to right hand side. So sine 90 minus theta into cos 90 minus theta, you have to prove is equals to tan theta upon 1 plus tan square theta. So what I will do, I will try to prove this expression as something. So sine 90 minus theta, I can write it as cos theta, and cos this expression I wrote as cos theta and sine theta. Let us try to find out what is this expression as. Tan theta, I can write it as sine theta upon cos theta. I have shown again why tan theta is sine theta upon cos theta with concept proof. And tan square theta, I can write it as sine square theta upon cos square theta. So now this will become sine theta upon cos theta. If I take LCM here, this will become cos square theta plus sine square theta upon cos square theta. So this will become sine theta upon cos theta. Cos square theta plus sine square theta is 1 upon cos square theta. So this I can write it as sine theta upon cos theta into cos square theta will go in the numerator. So sine theta, 1 cos theta here and 1 cos theta here will get cancelled to sine theta cos theta. So this expression also turns out to be sine theta cos theta. So I have proven this, both the sides are equal. Now solving this kind of sums initially is okay, but if you have to solve it a little faster way, what I will do is I will basically solve it like sine 90 minus theta cos 90 minus theta, but this knowledge will come when you practice a lot. So I will write sine 90 minus theta is cos theta and cos 90 minus theta is sine theta. But when I'm seeing there, I have to prove it as tan theta upon 1 plus tan square theta. So how do I do that? So I need tan theta here, so I will need 1 cos theta here. But since I have divided this expression by cos theta, I will multiply also by cos theta. So now this cos theta and cos theta will become cos square theta, and sine theta upon cos theta I can write it as tan theta. Now cos square theta I can write it as 1 upon sec square theta into tan theta. And now I know sec square theta is what? Nothing but 1 plus tan square theta. Why? Because I know the identity sec square theta minus tan square theta is 1. What does this imply? Sec square theta equals to, if I take tan square theta on that side, 1 plus tan square theta. So see, here you don't have to prove this side also as sine theta cos theta. It will save almost 30 seconds or 1 minute of yours. Let's take some challenging sums. So it goes like, you have to prove 2 sec square theta minus sec raised to 4 theta minus 2 cosec square theta plus cosec raised to 4 theta is equal to cot raised to 4 theta minus tan raised to 4 theta. So this is what we have to prove. So let us say I can see in these two terms, I can take sec square theta common. Correct? So this will become 2 minus sec square theta. In these two expression, I can take cosec square theta common. So this will become 2 minus cosec square theta. Okay. Now this will become sec square theta. Now I know sec square theta, I can write it as 1 plus tan square theta. Yes or no? And here I can write cos x square theta as 1 plus cot square theta, because cos x square theta minus cot square theta is 1. So cos x square theta would be 1 plus cot square theta. So this expression will become sec square theta. 2 minus 1 would be 1, and it will be minus tan square theta. And here it will be cos x square theta. Again 2 minus 1 would be 1, and it will become minus cot square theta. Okay. Now again sec square theta I can write it as 1 plus tan square theta. Yes or not? Because sec square theta minus tan square theta is 1. So sec square theta is 1 plus tan square theta. And this I will write it as 1 minus tan square theta. Now cos x square theta I will write it as 1 plus cot square theta using the same identity, minus cot square theta. Okay. So now we have reached this stage. So is this expression not equal to a plus b and a minus b types? So we can write this as a square minus tan square theta the whole square. Okay. And that also I can write it as minus 1 square minus cot square theta the whole square, a square minus b square, in that form. Okay. So now this will become 1 minus tan raised to 4 theta minus 1 minus cot raised to 4 theta. So if I open the brackets up, this wall will get cancelled with this. What I am left with is cot raised to 4 theta minus tan raised to 4 theta. So we have proven what we've been asked for. Okay. Let's go next. Let's take some more interesting sums. You have to prove 1 plus cosec A upon cosec A equals to cos square A upon 1 minus sin A. Okay. So let's start with the left hand side, and we will eventually come and prove that it is equals to right hand side. So I know cosec A is 1 upon sin A, reciprocal of sin. And again cosec A I can write it as 1 upon sin A. Okay. So this becomes, I will take LCM, so it will become sin A plus 1 upon sin A, and this will be 1 upon sin A. Now this sin A and this sin A will get cancelled. So in numerator there is 1 upon sin A, and denominator there is 1. Now since I need cos square A up and I need 1 minus sin A in the denominator, I will rationalize it by 1 minus sin A here, and I will put 1 minus sin A here. I have not changed the expression at all. Then 1 plus sin A into 1 minus sin A plus b, a minus b will become 1 minus sin square a square minus b square, and down it will be 1 minus sin A. Now 1 minus sin square A is what? Cos square A. Because we know sin square A plus cos square A is 1. So cos square A, if I take sin square A on that side, so 1 minus sin square A will become cos square A. And this is what we have been asked to prove. Okay, let's take another sum. Let's take this one. We have to prove root of 1 minus cos A upon 1 plus cos A is equals to cosec A minus cot A. Okay. So now in the left hand side we have square root, in the right hand side we don't have the square root, which means we'll have to address the square root. And to address the square root we'll have to remove the square root, which means I will need square inside. So I will rationalize. How I will rationalize? I will rationalize basically the denominator. So if I have to rationalize the denominator, I will do it as 1 plus cos A, I will multiply, and 1 plus cos A I will divide. inside the square root. Correct? So now this becomes a minus b, a plus b. So 1 minus cos square a square minus b square. And this will become 1 plus cos a the whole square. So 1 minus cos square a is sin square a, because sin square a plus cos square a is 1. So 1 minus cos square a will become sin square a. You can use that identity. And here it is 1 plus cos a the whole square. Okay. Okay, since we have cosec a minus cot a in the numerator, then we should have actually done the reverse way. I would have rationalized the numerator. So this would have been minus. So this would have been 1 minus cos a the whole square, and this would have been 1 minus cos square a. So this will become 1 minus cos a the whole square upon sin square a. Okay. Now if I take it out from the square root, 1 minus cos a का whole square root से बाहर आके क्या बन जाएगा 1 minus cos a, और sin square root से बाहर आके क्या बन जाएगा sin a. Now I can split this. I can do it as 1 upon sin a minus cos a upon sin a. So 1 upon sin a is cosec a, and cos a upon sin a we know it's cot a. So we have proven that. Okay. So our operations should depend upon what has been asked. So if it would have been 1 upon cosec a minus cot a, then I would have done it in a manner where I would have rationalized the denominator. Okay. Next. So what I'm doing is I'm trying to take those kind of sums which normally most of the tutorial classes will not do. They will do the simpler ones, but I'm taking a mix of medium difficulty and difficulty ones so that you understand it probably, because in my previous lectures in 9th I've done a lot of simpler ones. So let us try to bring our level a little notch up. So the sum goes, you have to prove cosec raised to 6a minus cot raised to 6a is 3 cot square a cosec square a plus 1. This is what we have to. Now, if you see this, if we have to solve any proving sum in trigonometry, we have to solve through identities only. So which means to solve this sum, I will have to use an identity of cosec square a minus cot square a is 1. So I have to somehow use this. And also if there is a raised to 6 here, which means I will first bring this term cosec square a and I will do a cube. And I will bring cot square a and I will do a cube. So I got cosec square a and cot square a. Now this expression has turned into something like a cube minus b cube. And in 9th grade, we have factorized this by a minus b the whole cube plus 3ab into a minus b. We have factorized this expression something like this. So we'll use the same factorization technique. So this is a cube minus b cube. I will factorize this as a minus b the whole cube plus 3 times of a, which is cosec square a, b, which is cot square a, into a minus b. A is cosec square a and b is cot square a. Understood? Now it becomes pretty simple. Cosec square a minus cot square a is always 1, so this will be 1 cube plus 3 cosec square a plus into cot square a. And this also would be 1. So ultimately it became 1 plus 3 cosec square a cot square a. So this is what we have to prove. Okay. So you have to be very well versed with all the factorization, algebraic formulas. In all my lectures, if you find that I'm taking efforts to prove all those concepts, to prove all those formulas, please, I would recommend do not mug up the formulas. I advise all my colleagues and my teachers also to show the proof of concept. If you do the proof of concept, then your mind is convinced about that particular formula and you're able to apply that properly. Just don't do it like ये रट लो और फिर ये सम को अप्लाई कर दो. नो नो, इट विल नॉट वर्क वे, बिकॉज वो रटने से आप भूल जाओगे. और अगर आपने फॉर्मूला को प्रूफ किया है तो आपने वो प्रोसेस किया है, तो अगर वो फॉर्मूला याद भी नहीं रहा तो तुम अपने आप वो फॉर्मूला साइड में बना सकते हो. ओके, सो दिस सम इज cot theta plus cosec theta minus 1 upon cot theta minus cosec theta plus 1. You have to prove this as 1 plus cos theta upon sin theta. It's a very interesting sum. So let us see how do we handle this. So since I have given this expression which involves cot theta plus cosec theta, in my mind, I know somewhere I have to use this identity. Okay. So now, if I take this 1, see what I'm doing. I can write this 1 as cosec square theta minus cot square theta. I can replace this 1 by this because ultimately this is 1 only. And down I will keep it same. आप बोलोगे कि सर आपने नीचे क्यों नहीं किया ऐसा? Because the intention is कि we should do something by which this denominator term I will be able to cancel out by taking something common on numerator. Let's see what happens. So this will become cot theta plus cosec theta minus, this is a square minus b square. So I can write it as cosec theta plus cot theta into cosec theta minus cot theta. So this is no brainer. And I have in denominator cot theta minus cosec theta plus 1. Now if you see, here there is cot theta plus cosec theta and here there is cot theta plus cosec theta. So that I can take common. So I can take cot theta plus cosec theta common. So if I take this common, so here it has gone out, so it will remain 1, and here it will be minus cosec theta minus cot theta. Understood? Upon cot theta minus cosec theta plus 1. So now I will write this as cot theta plus cosec theta. Now I will open this small bracket, which will be 1. I will take cot theta first, which will minus into minus plus 1 plus cot theta minus cosec theta. Understood? And now I have, I will write this also as 1 plus cot theta minus cosec theta, just rearranging the terms. Now if you see, this and this will got cancelled. I am left out with cot theta plus cosec theta. Cot theta I can write it as cos theta upon sin theta. Cosec theta I can write it as 1 upon sin theta. If I take sin theta common, 1 plus cos theta. This is what I was asked. So you see, just by using the identities, understand one thing. Any proof sum or any trigonometrical sum, you have to solve through identities, using identities or using the basic concepts of trigonometric ratios. Okay. Let's try to take some more challenging sums. So like sin cube A plus cos cube A upon sin A plus cos A plus sin cube A minus cos cube A upon sin A minus cos A equals to 2. You have to prove this expression is equal to 2. So again, if you see here, this is of type a cube plus b cube. which we have learned two formulas of this: a plus b the whole cube minus 3ab upon a plus b. You can watch my lectures of algebra formulae where I've shown all this with proofs. I've done the proofs of all these things. So, and also I can write a cube plus b cube as a plus b, a square minus ab plus b square. So this sine cube a plus cos cube a, I will use this formula. So I can write this as, why I am using this formula? Because I know if I do sine a plus cos a here, it will get cut with the denominator. So that's why I'm using this formula. Sine a plus cos a into sine square a minus sine a cos a plus cos square a. So this I factorized as this. And there is sine a cos a down plus cos a down. And this I will use this formula. A cube minus b cube, I have again two formulas. A minus b the whole cube minus plus 3ab into a minus b, or I can write it as a minus b a square plus ab plus b square. You can refer to my lectures where I have shown the proofs of this. Okay, so this I will write it as sine a minus cos a into sine square a plus sine a cos a plus cos square a. Simply applying that formula, sine a minus cos a. Okay. So now this sine a plus cos a will cancel out. This sine square a plus cos square a will become 1, which will be n minus sine a cos a here. This will cancel out here. Sine square a plus cos square a there also will become 1, and there will be plus sine a cos a there. Now this sine a cos a and this sine a cos a will cancel out. 1 plus 1 is 2. So we have proven this. So if you see, any of the sums you have done so far will not take more than 5 to 6 steps. But you should be very strong in your trigonometric identities and your algebraic formulas and factorization. Very interesting sum. Sine A. So this I am going to, it's going to take a little more space. So I am going to write it. You have to prove sine A plus sec A the whole square. Plus sec A the whole square plus cos A plus cosec A the whole square is 1 plus sec A cosec A the whole square. This is what we have to prove. So as usual, let's start from left hand side. So I'll expand this sine square A plus sec square A plus 2 sine A sec A. I can write this as this. Again, and this I can write it as cos square A plus cosec square A plus 2 cos A cosec A. So this is one I wrote. Now this sine square A and this cos square A together will become 1, and this sec square A, I will write it as 1 upon cos square A because sec A is reciprocal of cos A. This cosec square A, I will write it as 1 upon sine square A. Okay. And these two terms, I will take 2 common, and sine A sec A. To sec A, I will write it as 1 upon cos A, and here it is cos A. Cosec A, I will write it as 1 upon sine A. So this became this way. So now it is 1 plus. Now in this 2, I will take sine square A, cos square A, like this. Sine square A, there it will be cos square A. And the LCM would be cos square A sine square A. I can do this way. And here, I will again take here LCM sine square A plus cos square A upon sine A cos A. Okay. So my expression now became 1 plus, this is 1 sine square a plus cos square a, and 1 upon cos square a I will again write it as sec square a, and 1 upon sine square a I will again write it as cos x square. And here this again will be 1, so 2 into 1 is 2. 1 upon sine a I will write it as cosec a, and 1 upon cos a I will write it as sec a. Now if you observe this expression, 1 plus sec square a cosec square a plus 2 cosec a sec a is nothing but it is a plus b the whole square. 1 plus sec a cosec a का square, and that's what I've been asked. तो इसको भी अपन ने 4-5 steps में कर दिया. So try to practice this more and more, and I think you will definitely try to do this kind of proving sums very well. There is nothing in that, just need a little bit of practice and just do the proofs of trigonometric identities and you will be able to crack this kind of numericals. Let us try to do some different kind of sums now. So one interesting thing which I want to, so sometimes you have been given some trigonometric equation in form of some trigonometric ratios, and then you have to prove something. So for example, I have a sum here which is, you have been given cosec theta minus sin theta is root 3. This is given to you. And you have to prove cosec theta plus sin theta is 3. This kind of sums. Okay. So let us try to understand how we do this. So I have been given this and I have to find this. So the best way to do this is, because if I have to find cosec theta plus sin theta, then I need the terms cosec theta plus sin theta, which means I will get it by squaring this. So if I square this, I will get cosec theta minus sin theta the whole square is root 3 ka whole square. If I square this out, I will get cosec square theta plus sin square theta minus 2 sin theta cosec theta equals to 3. Now you just imagine, how will I get cosec theta plus sin theta? What is the square of this? It will be cosec square theta plus sin square theta plus 2 sin theta cosec theta. This is the square of cosec theta plus sin theta the whole square. इसका square है. But for that I need plus 2 sin theta cosec theta. But what I have over here, I have minus 2 sin theta cos theta. So what I will do, cosec square theta plus sin square theta, I will add 1 2 sin theta cosec theta, and then I will subtract also 1 2 sin theta cosec theta. So this both will cancel out. So I have made no effect, and this which is there already, I will write it as 2 sin theta cosec theta equals to 3. Understood? Now what happens is that this now becomes cosec theta plus sin theta the whole square. Yes or no? And this will become minus 4 sin theta cosec theta equals to 3. Now we know sin theta and cosec theta are reciprocals of each other, so they will cancel out. And then it was root 5. Sorry, my mistake. So this will become 5. So this will be 5, right? And this will be 5. Sorry. So now cosec theta plus sin theta the whole square. Now if I take this 4 on that side, it will become 5 plus 4, 9. Now I will simply take square root on both the sides. I will get cosec theta plus sin theta is plus minus 3. But normally in ICSE board in 10th grade when you are learning the trigonometric ratios between 0 to 90 degrees. So that lies in first quadrant. So all trigonometric ratios value in first quadrant is always positive. So I will, cosec theta is positive, so sin theta also will be positive. So it's both the answers when I add positive to positive, answer also would be positive. So answer is 3. Okay, let's move ahead. If 1 plus sine square theta is 3 sine theta cos theta, this is given to you. Prove that tan theta is either 1 or 1 by 2. So this is what we have been asked. So how do we do this kind of sums? So if I have an expression here 1 plus sine square theta, can I write this 1 as sine square theta plus cos square theta? This 1 can be written as sine square theta plus cos square theta because it is always 1. And plus I have another sine square theta here. And I will take this 3 sine theta cos theta here. I will make an equation. Because I need tan theta. So somehow I need to convert this expression and make it into some expression in tan theta. So that's why, and we are going to use our factorization skills in this. So I know sine square theta plus cos square theta minus 2 sine theta cos theta is sine theta minus cos theta the whole square. So what I will do is I will borrow minus 2 sine theta cos theta from this term and write it over here. Okay. And here it will be sine square theta. So if I've given 2 sine theta cos theta here, what will be left here? 1 sine theta cos theta equals to 0. Okay. Now, this term, I can write it as sine theta minus cos theta the whole square. And here, I can take sine theta common. So this will become sine theta minus cos theta equals to 0. Now, in both these terms, there is sine theta minus cos theta which is common. So I will take sine theta minus cos theta common. So what will be left out in the bracket? It will be sine theta minus cos theta plus sine theta. Yes or no? Because 1 sine theta minus cos theta came here. So uska square ka ek yahan bach jayega, and this sine theta cos theta went out. So only sine theta will be left here. So now equals to 0. Which means sine theta minus cos theta into 2 sine theta minus cos theta equals to 0. So my expression now turned out to be this. Now product of two numbers is 0. When it is 0? When either the first number becomes 0 or your second number becomes 0. If any one of them becomes 0, the product of two numbers will become 0. Which means from here I can say sine theta should be equals to cos theta. Or I can say if I take cos theta in the denominator, sine theta upon cos theta is 1. Which means sine theta upon cos theta is tan theta is 1. And if I do here, I will do sine theta equals to cos theta. I take cos theta on that side. And I will bring cos theta in the denominator here. And this 2 I will take there. So tan theta is half. So we have proven that if 1 plus sine square theta is 3 sine theta cos theta, which means tan theta has to be either 1 or tan theta has to be half. This is what we were asked. So if cos theta plus sine theta is given as root 2 cos theta, this is given to you. You have to prove cos theta minus sine theta is equal to root 2 sine theta. So this is what you have to prove. So how we do it? So here, since I have one expression in cos theta plus sine theta and one expression in cos theta minus sine theta, so I will try to square them एंड व्हेन आई स्क्वायर देम, इसके अंदर एक +2 sin थीटा cos थीटा आएगा, वहां पर एक -2 sin थीटा cos थीटा आएगा, और दोनों को जब मैं ऐड कर दूंगा तो वो कैंसिल आउट हो जाएंगे। तो वो वाली टेक्निक यूज करता हूं मैं। सो व्हाट आई विल डू, आई विल ट्राई टू फॉर्म this like this. So this is given to me, that I have to find. So I will say let cos theta minus sin theta be equals to k, and k is something which I have to find, and I have to prove that is equals to √2 sin theta. Okay, now this is my equation number 1 and this is my equation number 2. I will square both. So if I square equation number 1, it will be cos square theta plus sin square theta plus 2 sin theta cos theta equals to 2 cos square theta. No? This also I'll have to square. And this if I square, it will be cos square theta plus sin square theta plus minus 2 sin theta cos theta equals to k square. Okay, this became like this. Now I will add both this. So this equation became 3 and this equation became 4. So now what I will do, I will do 3 plus 4. So if I do 3 plus 4, cos square theta plus sin square theta is 1. Here also cos square theta plus sin square theta is 1. So if I add both this, it will become 2. When I add this, we cancel out. So here only 2 will remain. And what will be there? There will be 2 cos square theta plus k square. Okay? वो दोनों साइड ऐड हो जाएगा उधर भी. So now I will take 2 minus 2 cos square theta is k square. I will take 2 common here, it will become 1 minus cos square theta is k square. Now 1 minus cos square theta is sin square theta k square. So let me write it as k square is 2 sin square theta. Now I will take square root on both the sides, so it will become plus minus √2 sin theta. Yes or not, if I take square root? So either it is plus √2 sin theta or it is minus √2 sin theta. We have been asked to prove it is plus 2 root sin theta. So yes, it can be plus 2 root sin theta. So we have proven this.